Good morning. Today we are doing a mini unit on Chapter 8. Today we are applying exponent properties involving products. So products means we are multiplying. I'm going to go back for 1 second to our learning target. It says I can apply properties of exponents to simplify expressions. It does not say solve. We are not solving anything today. We are simplifying or making our exponents or our equation smaller. So first we're going to look at this first part here. The big number is what we call our base and the small number is our exponent. So here this is 7 to the power of 3, or 7 3 times. So this is really 7 times 7 times 7. I'm going to make a little table here so we can count up how many 7s we're going to have total. This is 3 7s and this is 5 7s. So total, how many 7s would we have? Well, 5 and 3 more would make a total of 8. So our answer is 7 to the power of 8. I'm going to make this a little bit smaller. 7 to the power of 8. We are not going to plug this in our calculator. That is simplified. We are not solving, just combining how many 7s do we have total. Over here we're going to do the same thing. I like to make a little table to count up how many of each number I have. This is really an exponent of 1. So this is 9 one time. This is 9 8 times, 9 times 9 times 9 times 9, 8 times. And this is 9 2 times. So total, how many 9s do we have? We have 9 times 9 times 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So 9 to the exponent, or to the power of 11. This next one looks a little confusing because there's parentheses, but this is really -5 one time, and this is -5 6 times. So how many -5s would we really have? Well, 6 here and 1 more make a total of 7. So we have -5 7 times. Notice, this is different than this. We need the parentheses because it's -5 times -5, not 5 times 5 times 5, then it's negative. So we have to have it in parentheses because it's a -5 times a -5 times a -5, 7 times. So there's our answer. Here's the same thing, but with x's. I'm going to make my little table here. This is x to the power of 4, or x times x times x times x 4 times. And this is x multiplied 3 times. So how many x's do I have total? Well, 1, 2, 3, 4, 5, 6, 7 x's. That's x multiplied 7 times. Alright, so all these ones we had multiplied. They were just next to each other. So we counted up how many we have total. Now I have parentheses. Just like back here, the exponent told me how many times to write this x. On this one, the exponent on the outside tells me how many times I should write whatever's in parentheses. So I'm going to write whatever's in my parentheses here 3 times. 2 to the 5th times 2 to the 5th times 2 to the 5th. Make all my 2's look the same. So now we wrote that 3 times. 1, 2, 3. Now we can count up how many 2's are we really going to have. Well, this is 2 times 2 times 2 times 2 times 2, 5 times. Same thing here. And same thing here. So how many 2's do I have total? Well, 5 and another 5 and another 5, 5, 10, 15. So 2 to the exponent, or to the power of 15. Alright, this next one, always look at your outside exponent first. These are brackets or parentheses. We write whatever's inside there 5 times. So I'm going to write -6 squared 5 times. -6 squared, -6 squared, -6 squared, -6 squared. I wrote that 5 times. 1, 2, 3, 4, 5. Now I can count up how many -6's do we really have. Well, this is -6 2 times. This is negative 6 2 times, 2 times. Some of you can figure this out without writing it out every single time. That's okay. So we have a negative 6 how many times? Well, 2, 4, 6, 8, 10 times. So the exponent is a 10. It's not negative 6 times 10, it's negative 6 10 times. Negative 6 times negative 6, and so on. Alright, down below here, same thing. Whatever's inside our parentheses, we're going to write however many times it says, 4 times. So x squared, x squared, x squared, x squared. So each of these is really how many x's? Well, there's 2 x's here, 2 here, 2 here, and 2 here. So for a total of 2, 4, 6, 8. Notice when I count them up, I'm only counting up the ones in the table, not from the top. Alright, this next one's a little bit tricky. We have a whole big set of parentheses here. Doesn't matter what's inside, we're going to write it 2 times. 9xy times 9xy. Now if I make a table, there's only one 9, one x, and one y. So it's kind of silly to write it again. If you want to, you can. But we need to just count up how many 9s do we have? Well, we have 2 9s. So this would be 9 times 9, which is 9, 2 times 9 squared. Then we have how many x's? We have 1 x here and 1 x here, so that's x squared. And then we have 1 y here and 1 y here, that's 2 y, so that's y squared. So this is our answer. 9 squared, x squared, y squared. We have 2 9s, 2 x's, and 2 y's. Same thing on this next one. We're going to write whatever's in parentheses 3 times. 7ab, 7ab, 7ab. Since there are no exponents, we can just count up how many of each we have. These are all really multiplied. So how many 7s do we have? Well, we have 1, 2, 3. So we have 7 to the power of 3. We have 1, 2, 3a, so we have a to the third. And our b's, we have 1, 2, 3, we have b to the third. Notice we always go in alphabetical order first, numbers, and then our letters. So that would be our answer. Let's try a couple more. We're going to write whatever's in parentheses 2 times. Negative 4z times negative 4z. We technically don't need the parentheses anymore, so if you don't want to write those and you just want to write multiplication in the middle, that's fine. So if you know these two numbers are multiplied, that's fine. So we're going to count up how many negative 4s we have. We have negative 4 2 times. Notice it's in parentheses because we have negative 4 times negative 4. And then how many z's do we have? We have 1 z here and 1 z here. That's 2 z's, z squared. So now I'm actually going to evaluate this first part. A negative 4 times a negative 4 makes a positive 16, and we have z squared. So on these last ones, if you wanted to multiply 9 squared, like if you wanted 9 times 9 is 81, x squared, y squared, that would have been an okay answer as well. Same thing here, you could have multiplied 7 times 7 times 7. The reason why I've multiplied this one out is because this question is almost identical. It's just a little bit different because the negative here is on the outside instead of on the inside. So we're only going to write 2 times whatever's on the inside, 4z and 4z. This negative is really a negative 1 out front. So when we count up what we have 4 2 times, 4 times 4, 4 squared, and we have z 2 times. But we also have it multiplied by a negative 1. So we know 4 squared, 4 times 4 is 16, but times the negative 1 is now a negative 16, and we have z squared. So the only difference between these two problems is that the negative was on the inside, so our answer is positive, because a negative times a negative makes a positive. And here it was on the outside, so it's just telling us whatever you get, your answer's got to be negative. Alright, this one has an exponent, so I'm going to make my little table here. I have a 6 and an R, and here I have an 8 and 2 R's. Since these aren't the same number, let's just multiply them. 6 times 8 is 48. And we have 1, 2, 3 R's, or R to the power of 3. Alright, this next one we have 2 pieces, so we're just going to take them one piece at a time. Let's first look at just this one. It has an exponent of 2, so I'm going to write whatever's in parentheses 2 times. 2x to the third times 2x to the third. Then this piece I have times x to the 4. So I see lots of exponents, so I'm going to make my table to count up how many I have of each. I have a 2 and 3 x's here. I have a 2 and 3 x's here. And here I just have 4 x's. So let's count up our numbers first. I have 2 2 times. We can write that as 2 squared. Or, hopefully you know, 2 times 2 is 4. If you want to multiply those right away, that's okay. And then how many x's do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's, so x to the power of 10. That's as simplified as we can get. Alright, our last slide. We're going to write whatever's in parentheses 4 times. So 9m to the third n, 9m to the third n, 9m to the third n, and one more 9m to the third n. I see exponents, so I'm going to make my little table to count up how many I have of each. In every one here I have a 9. In every one I also have 3 m's. And I also have an n in every one. That's n to the power of 1. There's only one n in each one. So let's count up what we have. How many 9's do we have? Well, we have 1, 2, 3, 4. So 9 to the exponent, or power of 4. Then our m's. Count up how many m's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. M to the power of 12. And then last n, we have 1, 2, 3, 4, n to the power of 4. So that's our answer. We combine all of the numbers and letters that we have the same. Next one, let's write this out 3 times. 8x squared y to the 5th, 8x squared y to the 5th, 8x squared y to the 5th. So I have some exponents, so I'm going to make my table so I can count up how many I have total. In each one of these I have an 8. In each one of these I also have x squared, which is 2 x's. And then I also have y to the 5th. So that's 1, 2, 3, 4, 5 y's. 1, 2, 3, 4, 5 y's. So total, my answer, I have how many 8's? I have 1, 2, 3, 8 to the third. How many x's do I have? Well, I have 2, 4, 6, x to the 6th. And then my y's, I have 5, 10, 15 y's. So there's my answer. These last 3 are finding the missing exponents. So they're already telling us what our answer is. We need to figure out how many do we need here in order to get that answer. So let's take a look at this first one. We have 4 x's here. That's x to the 4th. How many more do we need to get to 5 total? Well, hopefully you know 4 and 1 more x would give you 5. So the question mark right there, we need 1 more x. So the exponent would be a 1. This next one we need to be careful on. We know in the end we need to have 16 y's. So I'm going to write out 16 y's. I know I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And over here, I have a group, I know it's in parentheses, of 8 y's. I need to know how many groups of 8 y's do I need. So if I already have 1, 2, 3, 4, 5, 6, 7, 8, this is one group of 8. How many groups of 8 do I need to get to 16? Well, I need one more group, right? I would need 8 more y's in here. So they're asking us, how many groups do we need? How many times would we write this out? Well, one here and one here would be a total of 2. So our question mark would be a 2. We would need 2 groups of 8 to get us to 16. And our last question here, I know we need to get to 8 and we need 15 z's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 z's. And I know that, let's take a look here, we have parentheses, so we have some groups. We know there are 3 groups. We're not quite sure what's in there, but we know there's 3 groups. So I'm just going to make some parentheses, or even circles, to represent 3 groups. 1 group, 2, and 3. So I know that there's a 2 in each group, and we know we need some sort of z's. Well, I know 2 times 2 is 4, times 2 is 8, so we did get this 8, that's good. We multiply 2 times 2 times 2, we get 8, that'll work. But we need how many z's in each group to get to 15 total? Well, if you look, I happen to write mine in groups. We would have 3 groups of 5. So we would need 1, 2, 3, 4, 5 z's here. 1, 2, 3, 4, 5. These are 2's. And then we have 5 z's in each. So our question mark, what we are missing right there, we would need 5 z's in each group in order to get to a total of 15. If this one was a little confusing, I know this one can be challenging, so please ask questions about that one. Otherwise, your homework is simplifying exponents. Please do not just use your calculator because you will not get the correct answer. We are just simplifying. We are not solving. Good luck.